Hello, I'm Carlos Suarez and this is the CRS channel. We are going to continue with word problems in our pre-calculus exercises and problems series. Okay, here we have an army of ants marching across the kitchen floor. If they form columns of 10 ants per column, then there are 6 ants left over. If they form columns with 7, 11, or 13 ants per column, then there are 2 ants left over. What is the smallest number of ants that could be in this army? We're going to define the following variables. M1 is the number of columns of 10 ants per column. M2 is the number of columns of 7 ants per column. M3 is the number of columns of 11 ants per column. M4 is the number of columns of 13 ants per column. So the total number of ants is going to be equal to either 10 M1 plus 6, that means 10 ants per column times the number of columns of 10 ants per column plus 6 ants that are left over. It is also equal to 7M2 plus 2, which is the number of ants per column, in this case 7 ants per column, times the number of columns of 7 ants per column, plus 2 ants that are left over. The total number of ants is also equal to 11M3 plus 2, which is 11 ants per column, times M3, which is the number of columns of 11 ants per column, plus 2, which is the number of ants left over. The total number of ants is also equal to 13M4 plus 2. 13 here being the number of ants per column, and for the number of columns of 13 ants per column, plus the 2 ants that are left over. Okay, which means then that 10M1 plus 6 equals 7M2 plus 2, which is equal to 11M3 plus 2, which is also equal to 13M4 plus 2. So let's relate M1 with M2, M3, and M4. Also relate M2 with M3 and M4, and relate M3 with M4. So from here we have that M2 equals 10 sevenths of M1 plus 4 sevenths. M3 equals, let's go down this column. M2 equals 10 sevenths of M1 plus 4 sevenths. M3 equals 10 elevenths of M1 plus 4 elevenths, and M4 equals 10 thirteenths of M1 plus 4 thirteenths. Okay, this comes out from simply subtracting this 2 from the 6 and then dividing by 7 to obtain the expression 4M2. For the expression 4M3, we'll subtract the 2 here and divide by 11. It gives you this. And for M4, subtract again the 2, which gives you 4 here, and divide by 13. Okay, now relating M3 and M4 with M2, we have then that if you use these two, well, you cancel out the 2's, and you know that M3 is 7/11ths of M2, and you equate this with this. The 2's cancel out, and you know that M4 is 7/13ths of M2, and if you use these two, then you cancel out the 2's, and you're left with M4 equals 11/13ths of M3. Okay, from this you have, according to these three equations, since M2, M3, and M4 have to be integers, whole numbers, that means that 10m1 plus 4 must be a multiple of 7, 11, and 13. That means that 10m plus 4 must be a multiple of 7 times 11 times 13, which is 1001. Okay, M2 must be then a multiple of 11 and 13, looking at these two expressions, so that M3 and M4 can be whole numbers, so that they can be integers. Which means that M2 must be a multiple of 11 times 13, that is, it must be a multiple of 143. Okay, we also have that M3 from these two expressions must be a multiple of 7 and of 13. That is, M3 must be a multiple of 7 times 13, that is, multiple of 91. And M4 from these two expressions, this one and this one, must then be a multiple of 11 and 7. So it must be a multiple of 7 times 11. That is, it must be a multiple of 77. 7m2 minus 4 must then be a multiple of 10. That is taken from this expression and this expression here, these two. Take the 6 to subtract to this side, and you're left with 10m2 minus 4. You divide by 10 and you get m1, which means that 7m2 minus 4 must be a multiple of 10. In the same way, if you take this expression and this expression, you have that 11m3 minus 4 must be a multiple of 10. And if you take this one and this one, you find that 13m4 minus 4 must also be a multiple of 10. Okay, so let's use this one. 10m1 plus 4 equals 1001 times a factor. Since 10m plus 1, 10m1 plus 4 is a multiple of 1001, then we have that 10m1 plus 4 is equal to 1001 times n, n being an integer. So we have that 10m1 equals 1001n minus 4. That is, m1 is equal to 1001n minus 4 over 10. Which means that 1001n minus 4 must be a multiple of 10. Okay, that means, of course, that n is not 0. It also means that n is not 1. It also means that n is not 2. and it also means that n is not 3, because if you multiply those numbers by 1001 and you subtract I4, you will not get a multiple of 10. So that means that n equals 4. That's the smallest number for n, which means then that 4 times 1001 is 4004. 4004 minus 4 is 4000, and 4000 is a multiple of 10, which means that m1 equals 400. That means that the total number of ants is 10m1 plus 6, which is 10 times 400, that's 4000 plus 6 is 4006. Okay, so we can also try to find M2, M3, and M4 now that we have M2, so that M2, now that we have M1, so that M2 is simply given by 10m1 plus 4 divided by 7, which is equal to 4004 divided by 7, which is equal to 4 times, remember that 4004 is 4 times 7 times 11 times 13, because 1001 is 7 times 11 times 13. So if we divide by 7 here, we are left with 4 times 11 times 13, which is 572. The same way, we have M3 equals 4004 divided by 11, and M4 equals 4004 divided by 13, which means that M3 is 4 times 7 times 13, which is 364, and M4 is 4 times 7 times 11, which is 328. Okay, we'll continue with our next problem in the next video.